In this final segment, we're going to reflect upon what we've learned and what happened with our guesses and everything else, as then we applied our theoretical model, the slope deflection method, to see what would happen in this beam. Let's go back here. We have a structure that is symmetric, at least in terms of the beam itself and in the support systems that we've got. It is not equal stiffness, though, although the stiffness is symmetric. The loads are not symmetric, and we also have a support movement that is not symmetric. As a result, when we were trying to guess, it became kind of complicated to figure out what was going on. So we pieced this apart in the guess into three different pieces. One where the load was only applied to the left, what might happen there, what would happen with the load at the right only, what would happen there. Those two were the same kinds of responses, but that support movement was going to do something different. Right? Now, truly in our guess, what we did was we just kind of hand-waved through how we might sum up those three sorts of effects. I have superposed at the very end the deflected shape that we drew that was based upon the calculated moment diagram. And just to illustrate some of the impacts of what's going on. Now, it's really not fair to compare directly now this blue line, this big dark blue line, and the orange line, because these are not coming from the exact same situations, right? The blue is from the support movement and the loading, as opposed to the orange is just from the support movement itself. I did this, though, because I wanted to illustrate just the impact of the support movement. Because if this was only about the loads, this is actually pretty easy to figure out the overall shape and behavior that's going to happen. But that support movement was the thing that drove the uncertainty, at least for me, as we approached. And you're also going to find out my estimates of moments were pretty far off. And I wanted you to see that I was really doing this authentically, and just how confusing it was to try to guess what was going on with the support movements and how much of an impact that might or might not have. And there's a lot to peel out about this. So, for instance, let's just focus on the moments first. The guess at the left end was, in effect, a frowny face moment of 200. We ended up with about 285. It's not so bad. Percentage-wise, that's kind of off, but it's not so bad. But then we go to this support where the movement's happening, and there's a huge impact. And indeed, we almost have zero moment there, almost as though there's effectively a hinge. We talked about that maybe we should look at our guess initially as a propped cantilever fixed in a roller there, break the internal moment continuity, see what happens. That turned out that would have actually been a really good, effective way to go about this, and it wouldn't have been too far off. And probably all the rest of the guesses would have been better had we done that. If so, we would have had 5/8 WL going over to this side for the vertical reaction. That would be 5 divided by 8 times 80 times 5. That would have been a 250 kilonewton reaction. And over there, we actually turned out to have a 257 equivalent shear or equivalent or a vertical reaction out there. And if I recall right, I don't recall right. Let's see, the moment would then be 0.375 times 80 times 5. That'd be the vertical reaction over here in the prop cantilever, times 5 for the moment, subtract off a WL squared divided by 2. Moment would have been about negative 250, and that would have gotten us, so the prop, work that through yourself. A prop cantilever, we would have had about a negative 250 if we'd used that compared to the 285. That's very interesting. A lot more that we can make out of that. All right, so, and we'll come back to that another time. Let's go back. Not great guesses here all the way along, and really kind of made some goofy kinds of guesses here about what might happen. This was actually a minus when we got down and looked at all these kinds of things. So, actually we were pretty decent out at the very far right. The reason, of course, is that that number, 225, was based upon two fixed ends and the loading effects on the first two parts. And that support is the furthest away from where the support movement happens, so its effect and impact diminished as we got all the way over. That's a important thing to kind of also big picture realize. The effect of that support movement is going to be experienced at multiple spans, but the further away we go, the less of an effect it will have. That's a big picture kind of idea. We had a ratio of 4 to 3 on the stiffness from the middle to the outside, so having twice the flexural rigidity was diminished a little bit by a longer span, so it's the EI over L effect that came along there, not just the EI alone. So we're seeing a little bit of an impact there. We almost have 3 equal spans. When we get into moment distribution, you'll see this impact even more, and what's going on inside the beam. What else do we want to talk about? Well, let's go back to the deflected shape. We had a dominating influence in the middle from these two outer loads, creating hogging curvature in the middle. The support movement alone would have created some positive. So that's kind of interesting. The support movement redistributed the moments, reduced significantly, and relaxed the moment at that point, but it didn't go so far as to create positive curvature in the middle. We still had that hogging curvature effect. It is interesting that 0.01 meters was just about enough to completely change what was going on in this middle. If we kept dragging it down even further, we would have gotten the smiley face to show up in this middle segment. So what does that mean big picture? How do you quantify what those effects are? And I would say that how you quantify that is you have to do a little bit more math, and that is you come back and you've got to start figuring out what the fixed end moments are that are coming from the loads and how that compares to the chord rotations. And that's, I think, part of the major piece that you've got to do, what the impacts are on all the fixed end moments from the chord rotation to begin to get a feeling for what the impact is going to be. And we didn't try that on this one. Had we might have been able to guess a little bit better about this coming closer to 0 the way that it did.